Hey guys, welcome back to another Kubernetes video. Today will be the intro to a series that I'll be doing on Kubernetes monitoring. In this video, we're going to look at what we need when it comes to a monitoring system, some of the components, and finally the broad view of the solution that we'll be going through in the subsequent videos. So let's get started. The first thing that we require are metrics. So what are metrics? Metrics are a measure of some quantity at a point in time. We need to be able to gather them from various sources. So we may have metrics that come from an application. We may have metrics that come from the servers that we're running our applications on. We need to be able to gather those from both those places and aggregate them and store them. They should then be made available for alerting, for troubleshooting, and just for verifying the state of the system at different points in time. This on the right hand side is a few examples of metrics. First one, memory bytes used. It's just a numeric value and a name. The second one has some additional information with the status code of a HTTP request and the frequency with which that has occurred. And then the third one is again a name and a value, the number of jobs in a queue at the current point in time. And these are all using the Prometheus metrics format, and that is the tool that we'll be looking into in subsequent videos. Next, we need a logging solution. So traditionally, logs will be stored wherever an application is run. However, in order for us to troubleshoot that, we need to go log into whatever server the application is running on, navigate to the correct directory, and then look at the logs using whatever tool we have, less or some other. We may want to grep for errors or something like that. However, this isn't the most optimal solution. Rather, we would like to be able to quickly access a centralized dashboard where we can see the logs without having to go and access particular machines. So that is what we are hoping to achieve with a logging solution in Kubernetes. There will be log collection, log aggregation, and log querying via a centralized dashboard. Next, when something goes wrong in the cluster, we want to be able to alert on that error. First of all, we want to be able to generate alerts, and this is generally done using thresholds on metrics. So we have defined what metrics are in the previous slide. Then we will take that metric, and based on being above or below a certain value, we will then create events as a result, and those events will be translated into alerts. We can then categorize the alerts. This means we may have different levels of priority. We may have info level alerts, warning level alerts, and critical level alerts. We can aggregate alerts. So if we have two different alerts that pick up the same condition in certain scenarios, then we can set up rules to aggregate in those scenarios. So for an example, if we have an alert that checks MySQL logs for any errors, and we have an alert for MySQL replication broken, then in some scenarios, when the replication breaks and an error is detected in the log, those may be aggregated together to create a single alert rather than having multiple alerts. We should also be able to silence alerts in particular scenarios. So for example, if we have to do some hardware maintenance and take a server down for a period of time, then during that maintenance period, we should be able to silence any alerts related to that particular piece of hardware. And this is a piece of functionality that we will also require. Finally, we need to be able to route alerts to various sources. So oftentimes there may be some dashboard that is monitored. There may be email addresses that it should be sent to, and there may be channels, Teams channels, Slack channels that it may also be sent to in order to warn engineers that something has gone wrong. So these are all functionality that we will require from our monitoring system. And finally, the proposed solution for Kubernetes, the most common solution that you will find, it is pretty much the standard at this point, and that is the Prometheus stack. So the Prometheus stack consists of Prometheus itself, which is the metrics collector, Alert Manager, which handles the functionality that I mentioned with regards to alerts, sends to various endpoints, and Grafana, which is our visualization dashboard where we can see information based on alerts, based on logs, based on different metrics at different periods of time. So we can create dashboards to analyze, to create graphs for different metrics that describe how our cluster is operating at a given period of time. Finally, Prometheus collects its metrics from various sources. So it could pull from node exporters, it could pull from Kubernetes components, kubestate metrics. It could even pull from a simple text file that we're writing to based on some logic that we have custom configured. However, regardless of that, the format that Prometheus gathers is the same, and the outcome is the same, in that it will allow us to generate alerts and it will allow us to view the metrics via Grafana dashboards. So that is what we will be looking at in more detail in our upcoming videos. So I hope that was a little bit informative. If you have any questions, please leave a comment. Please like and subscribe, and I will talk to you in the next video.